Assalamualaikum warahmatullahi wabarakatuh. To Promise Rita, our lecturer for GDC 2 DCG50173. Today, we would like to present about precise labeling. Okay, this is the group's name for this practical work. First, Haikal bin Azri, 10DGU20F 1001. Muhammad Fairuz bin Zulkifli, 01DGU20F1025. Muhammad Ali Hashimi bin Shuhaimi, 01DGU20F1026. Next, Nurul Ali binti Ahmad Rohaizat, 01DGU20F1009. Ajishirah Azira binti Sahimin, 01DGU20F1012. And lastly, Nur Syaidatul Umairah binti Mak Zainuddin, 01DGU20F1014. The contents for this presentation: introduction, objective, tools or instruments, procedure and analysis, result, and lastly conclusion. Okay, I will present about introduction of precise labeling. Precise labeling is a particularly accurate method of differential labeling which uses highly accurate labels and with a more rigorous observing procedure than general engineering labeling. It aims to achieve high orders of accuracy 1 mm per 1 km traversed. Furthermore, readings observed and recorded to decimals of a millimeter. A close is a difference between the starting level of the initial point for the outward run and that determined at the end of the return run. If the levels have been reduced correctly, this value should be the same as the difference between the sum of the rise and falls and also the difference between the sum of the back sides and fore sides.
This is objective for precise leveling fieldwork. First, we need to understand what is precise leveling and the needs of precise leveling. Second, to understand the method and instrumentations of precise leveling. Last but not least, to understand the concept of precise leveling. Tools that we use throughout the precise survey work. First, we use automatic precise level. Functions for automatic precise level is to automatically take level readings. Second, we use staff. Functions for staff is a level staff is tools for measuring vertical distance above the or below the line of collimation. Third, tripod. Tripod used for set up the automatic precise level tool. Fourth, bipod. Bipod used to hold staff tools during survey work. Last, staff base. These staff base are used to be as a base for precise level tools during work.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, nama saya Kevin Azri. Saya akan sambung pertanyaan ini di bahagian prosedur. Okay, dalam kerja labeling ini kami telah melalui iaitu serial 1, 2, 3, 4, 5 dan 6, 7 dan 8 dan TBM pendekatan tolong hujan dan TBM pendekatan dengan watan. Okay, the first one, kat situ kita nampak reading from middle point, iaitu point A kita akan dapat 1.4190 dan point B kita akan dapat 1.2520 dan different yang kita dapat iaitu 0.167. Okey, yang kedua pula reading iaitu from point C. Point A kami dapat 1.3180 dan point B kami dapat 1.480 dan different kami dapat iaitu negatif 0.192. Okey, ni adalah di bawah ni adalah jalan pengiraan iaitu different level between A dan B. Okay, iaitu akan tolakkan different point A dan point B Kita tambah dan bagikan 2. Okay, kita akan dapat 0.025. Okay, dan seterusnya total error. Kiraan total error. Dan kita akan dapat total error kita yang akan dapat 0.1645. Okay, next. Okay. Seterusnya ini adalah lakaran atau gambar rajah jalan kerja kami, iaitu kita boleh nampak di situ gambar pertama iaitu dari TBM1 ke TBM2, dan seterusnya kami baik dari TBM1 ke CRM4, dan kami akan ulang proses ini dari CRM ke CRM, dari TBM CRM sehinggalah ia menjadi segitiga. Okay, seterusnya saya akan serahkan pertanyaan ini kepada rakan saya.
Assalamualaikum warahmatullahi wabarakatuh. I will continue the presentation with the analysis. The following data is taken during the project. There are 10 routes that are travel and form 7 triangles. Among the routes taken are as below. This project runs for 2 weeks starting from 8 September until 22 September. Okay, here is the data from CRM 5 to CRM 6 and data from CRM 4 to CRM 5. Okay, the next slide is the data from the CRM 4 to CRM 6. You can see at the field book, we need to write backside, foresight, and the radius level. Also, we need to do the correction to get the true radius level, and then we need to calculate the misclose using the distance. So in this data, we get the level is close because the misclose is 0.002. So in uh, here is the image that we sketch the road on the location map that form a triangulation from the data CRM5 to CRM6 and CRM6 to CRM4. Also CRM4 again to CRM5. So here look first look like triangle. Then we continue to analyze the data from the CRM3 to CRM4 to get the new triangle. Then the data from the CRM5 to CRM3. Then the data from CRM5 to CRM3, and we sketch the route on the location map that form a triangle. The second triangle is at like the picture given. So here we get 2 triangle loop. And next, we continue to analysis the data from the CRM3 to TBM1 like TBM tolok hujan, and data from CRM4 to TBM1 to get the another loop, and the data given is already close when we do the work, the project work. Here is the new loop on triangle from TBN1 to CRM4 and CRM5. So we can see that just now we get 3 triangle from CRM5 until TBM1. So we can connect from the other point that have a reduced level already, and we can create the triangle from the reduced level. Okay, we can see here is the another loop that we continue from TBM1 and CRM4 to TBM2. That's TBM2 is TBM Watania. Here is the data from TBM2 to CRM4. The data also already closed and get the target. In this slide, you can see the data is from leveling TBM2 to CRM7, and then we start from CRM7 to go to CRM8, and we can get the another triangle. Before we close the triangle, the data we need to collect the data from CRM8 to TBM2, and then you can see the sketch of road on the location map that form a triangle. In this slide, uh, you can see the calculation height of Calimation. The total backside minus total foresight equal to total rise minus total fall, and equal to last reduced level minus first reduced level. In station CRM5 to CRM6, the height of animation is 0, and the miscurve of distance is 0.002. And the next is CRM4 to CRM5. The height of animation is 0.003, and the data misclose is 0.001. From station CRM4 to CRM6, the height of Kalimantan is 0.005, and the distance of misclose is 0.002. You can see the next CRM3 until CRM4, the height of Kalimantan is 0, and the misclose is 0.001. You can see the data that we collect from the level, and we calculate all of this is we get is close because it's under 0.003 like the in the lab sheet given.
Assalamualaikum warahmatullahi wabarakatuh. Saya Muhammad Zulkifli. Jadi sebenarnya saya akan meneruskan pembentangan berkenaan dengan result, iaitu hasil kerja kami yang telah kami dapat. Okay, seperti mana yang kita boleh lihat dekat gambar raja ni. Ini adalah hasil kerja penyelesaian labeling yang telah kami siap lakukan. Okay. Yang garisan merah tu adalah garisan laluan kerja kami semasa kami buat kerja penyelesaian labeling, di mana kami telah overlaykannya dengan menggunakan penyelesaian QGIS. Dan di sini juga terdapat beberapa CRM dan beberapa TBM kami lalui semasa kami buat kerja penyelesaian labeling. Sebagai contoh, kami lalui CRM 4 ke CRM 6 dan kami patah balik dari CRM 6 ke CRM 4. Okay, jadi saya rasa itu sahaja daripada saya. Sebelum saya akan menyerahkan slide tersebut kepada rakan saya, Muhammad Ali.
Assalamualaikum. Nama saya Muhammad Ali Hashimi bin Syuaimi. Saya akan meneruskan dengan conclusion. In conclusion, throughout the research leveling carried out at Campus B, untuk our project ni, we have learned how to use digital level tools in the correct way and the concept of predicted level. We also understand the concept of this work by moving from a known value point, for example, TBM, CRM, and so on. The way to move from that point must not cross each other and be in the form of a triangle. We can also learn the tool by reading 3 decimal point value because the tool is different from the leveling tool. The challenge that have been overcome obstacles such as buildings, trees, roads, and so on. We need to plan the appropriate movement from CRM to CRM. It also took us 3 weeks to connect all CRMs in the Polytechnic area. The reference we use are based on the standard sets by JUPAM and the notes prepared by the lecturer. Therefore, we can learn to use a digital labeling tool and know the value of each point. Uh, uh, that's all from us. Thank you. Arigato gozaimasu.